When working with fractions, you need to be familiar with some of the terminology. A fraction is made up of a numerator and a denominator. The numerator is the top number, and that represents the number of parts that we have. In this circle, we have 3 parts that are shaded. The denominator, or the bottom number, tells us how many parts are needed to make one whole unit. For this circle, we need 4 parts to complete it. 3/4 represents this fraction here. A proper fraction is where the numerator is smaller than the denominator, like 3/4, or 1/2, or 15/16. In all of these situations, the numerator is a smaller number when compared to the denominator. An improper fraction has 2 types. The first is when the numerator and the denominator are the same number, as in 4/4. The second type is when the numerator is greater than the denominator, like 11/2, or 11/2. Lastly, the mixed number is when we're combining a whole number with a fraction, like 2 1/3. In many instances, you'll want to convert a whole number to an improper fraction. To do this, take the whole number and write a 1 under it. Just like 5. 5 becomes a fraction when you write a 1 under it. To convert a mixed number into an improper fraction, you'll need to multiply the denominator to the whole number and then add the numerator. And that will all be over the original denominator. So we have 8 times 9 plus 3. We're going to follow order of operations. 8 times 9 comes first. That's 72 plus 3. That gives me 75. So 75/8 is our new fraction. This is an improper fraction because the numerator is larger than the denominator. To convert an improper fraction to a mixed number, we want to divide the numerator by the denominator. Notice how I've set up the problem. The numerator is underneath the division symbol. The 7 is on the outside. 7 will go into 103 14 times with a remainder of 5. That remainder will become the numerator of our fraction portion of the mixed number. The denominator will continue to be a 7. So 103/7 is equivalent to 14 5/7. There are a few things to keep in mind when multiplying fractions. First, when multiplying, we're just multiplying across. 7 times 9, that will give you 63, or 8 times 12 will give you 96. That's our new fraction. Now we always want to simplify fractions if we can, and in this case, if you divide both 63 and 96 by 3, you'll get a simplified fraction of 21/32. Another way to go about this is to simplify any fractions first before multiplying. In this example, 9/12 can be simplified. If I divide each term by 3, I get 3/4. 7 times 3 will give me 21, and 8 times 4 will give me 32. Notice it doesn't matter which way you go about it, you will get the same answer. In many instances, it may be easier to simplify first, so that when you're multiplying across, the numbers are much smaller. Sometimes when you're working with larger numbers and you multiply across first before simplifying, you may not be aware that you can simplify it. Just keep that in mind. The steps for multiplication get a little more complicated when we're working with whole numbers and mixed numbers. We always want to convert a whole number or a mixed number into an improper fraction. For this example, we have 5 times 13/15. We're going to convert 5 to a fraction by putting a 1 under it, and then simplifying first. Remember, you can always multiply across first and then simplify. When I simplify, I get 1/1 times 13/3. When I multiply across, I get 13/3. This is an improper fraction, and I want to convert it back to a mixed number. I'll get 4 1/3. I do this by dividing 13 by 3. 13 goes into 12 4 times, and that will give me 1 remaining amount, so 4 1/3. In this example, I'm multiplying two mixed numbers. Again, I want to convert these to improper fractions. That means I'm multiplying the denominator to the whole number and adding the numerator. 3 1/4 becomes 13/4, and 5 2/3 becomes 17/3. Now I can't simplify any of these fractions, so I need to do a little multiplication, and sometimes we need to write out that multiplication to get our answer, especially if we're not allowed to use the calculator for this particular part. I get 221 as my numerator and 12 as my denominator. Again, my answer is an improper fraction. To simplify, I want to convert to a mixed number. I'm going to do that by dividing 221 by 12. This will give me 18 5/12. Division is similar to multiplication. However, there's one additional step, and that's going to be the first step. So what we're going to do with the division problem is we're going to change it so that we can work it as a multiplication problem. To do that, we're going to flip the second fraction or take its reciprocal, and then we're also going to change the operation to multiplication. Now, a reciprocal is when you're flipping the terms. So instead of 3/16, it becomes 16/3. Notice the numerator that was 3 is now the denominator, and the denominator that was 16 is now the numerator. We're changing the division symbol to multiplication. Now that we've changed this problem to a multiplication problem, we can follow the rules that we've been practicing previously. If you can simplify first, do so, or multiply across and then simplify. Here we have 5/8 times 16/3. 8 will go into 16 2 times. 8 goes into 8 once. When I multiply across, I get 10/3, or as a mixed number, 3 1/3. When dividing with whole numbers or mixed numbers, like multiplication, we want to convert these to improper fractions. So again, with division, our goal is to convert our division problem to a multiplication problem. But before we can do that, we need to convert those whole numbers and mixed numbers to improper fractions. Then we change to multiplication, then we multiply and or simplify and multiply. So that's really important to remember. We never want to simplify a problem that still is a division problem. We only can simplify after it's been changed to a multiplication problem. So let's look at two examples here. The first one, we have 9/10 divided by 4, which is a whole number. We know we can make a whole number into a fraction by putting a 1 under it. So now to convert this into a multiplication problem, we're going to flip 4 over 1 to 1/4 and change to multiplication. I'm going to just multiply across and I get 9/40. And I can't simplify that, so that's my answer. For the second problem, we have two mixed numbers that are in the division problem. So again, I want to convert each of these to improper fractions. 10 4/5 becomes 54/5, and 2 1/2 becomes 5/2. Now you may be tempted to simplify first, but don't do that. First, we need to change this to a multiplication problem. That means we're taking the reciprocal of the second fraction, that becomes 2/5, and we're changing division to multiplication. Notice we cannot simplify first. We need to multiply straight across. We get 108 over 25. 25 will go into 108 4 times with 8 left over. My answer is going to be 4 8/25. The thing to remember is that when you're adding or subtracting fractions and mixed numbers, we always want to have a common denominator. Remember, the denominator is that bottom number. When you have a common denominator, you can perform the operation of adding and subtracting. So when we have 5/8 plus 1/8, the eighths is the denominator, and that will continue to be in our answer. All we need to do is add the numerators. 5 plus 1 is 6. Now 6/8 can be simplified to 3/4, and I went ahead and did that. I divided each term by 2 to get my simplified answer. When we're subtracting with whole numbers, in order to add or subtract fractions, you need common denominators. When you don't have common denominators, you need to find a multiple that both denominators will go into. Least common multiples is a concept in which you're finding common multiples of two numbers. To find the least common multiple of two numbers, you list off the multiples. If we look at 12 and 18, you can see I've listed them off. 12, 24, 36, 48, 60, 72, and so on. For 18, I've listed 18, 36, 54, and 72. Notice highlighted are two common numbers that both 12 and 18 share. The least of these is 36. 36 is the least common multiple. When adding or subtracting fractions and mixed numbers that do not have common denominators, you need to find a common denominator, create equivalent fractions or mixed numbers, and then perform the operation. In this example, we have 4/5 plus 2/3. Fifths and thirds need to be changed to a multiple that both 5 and 3 will go into. Say 15. 5 times 3 is 15. If I multiply the same factor to my numerator, I'll create an equivalent fraction to 4/5. 12/15 is equivalent to 4/5. I can multiply 3 by 5 to get 15. Therefore, 2 times 5 will give me 10. 10/15 is equivalent to 2/3. Both of these fractions now have the same denominator. Now I can perform the operation of addition. 12 plus 10 is 22. 22/15 is my answer. I can then simplify this to 1 and 7/15. In this example, we have two mixed numbers, 10 and 7/8 minus 4 and 3/4. 4 will go into 8, so I really just need to change this mixed number. 4 times 2 will give me 8, therefore 3 times 2 will give me 6. So 10 and 7/8 minus 4 and 6/8 will give me 6 and 1/8. Sometimes when you're subtracting with mixed numbers, you may have to borrow. In this example, we have 3 and 2/7 minus 2 and 3/4. Before doing anything, we have to find a common denominator. 28 is going to be that number. 7 times 4 is 28, therefore 2 times 4 is 8. And 4 times 7 is 28, therefore 3 times 7 is 21. Now we have 3 and 8 28ths minus 2 and 21 28ths. Notice in this case that the numerator of the second number is larger than the numerator in the first number. In order for us to subtract 21 from 8, we need to borrow 1 from the whole number. We can rewrite this as 2 and 28 28ths. And that's because 28 28ths is equivalent to 1. Therefore, 2 plus 1 is 3. And then if we add that to 8 28ths, we should have the same amount that represents 3 and 8 28ths. Instead, we're repackaging it to look like this, 2 and 36 28ths. Now I can subtract 2 and 21 28ths. I get 15 28ths. A complex fraction is a fraction within a fraction. Sometimes the numerator is a fraction, sometimes both the numerator and denominator are fractions, or sometimes the denominator is a fraction. This can be true for mixed numbers as well. In this first example, we have 3/5 as the numerator and 6/7 as the denominator. We can read this as a division problem. So 3/5 divided by 6/7. And we already know how to divide. We flip that second one, change to multiplication, simplify if you can, and then multiply across. In this case, 3/5 times 7/6 can be simplified, and when we multiply, we get 7/10. Another example is when we have addition or subtraction in either the numerator, the denominator, or both. In this case, we want to simplify our numerator first before we do the division. 2/3 minus 1/2. Well, we need to find a common denominator first, which is going to be 6. 3 times 2 is 6. 2 times 2 is 4. 2 times 3 is 6. 1 times 3 is 3. 4/6 minus 3/6 is 1/6 over 4, or 4 over 1. Since we're dividing 1/6 divided by 4 over 1, we can change that to multiplication, 1/6 times 1/4, which gives us 1/24. When comparing fractions or mixed numbers, we're going to be using these comparison symbols. We always read these from left to right. So this is the less than symbol. If we had, say, 3 and 4, 3 would be less than 4. This one is greater than, again, reading it from left to right. 5 is greater than 2. And then, of course, equal to. We're all familiar with that one. In order to compare fractions or mixed numbers, what we want to do is make sure our denominators are the same. Then we can just look at the numerators. In this example, we have 3/7 and 4/10. If I find the least common denominator, which is 70, I can create equivalent fractions. 3/7 becomes 30/70, and 4/10 becomes 28/70. Notice that the numerator is larger on the left side. Therefore, 3/7 is greater than 4/10. When we compare 4 and 1/9 and 3 and 11/9, we want to be careful about what those fractions are. If we were just looking at the whole numbers, then clearly 4 would be larger than 3. But notice that the numerator is larger than the numerator here. So let's convert this 11/9 to a mixed number and then combine it with the 3. 11/9 is 1 and 2/9. When we add that to 3, we get 4 and 2/9. Therefore, 4 and 1/9 is less than 4 and 2/9, or 3 and 11/9. Like comparing fractions and mixed numbers, when ordering fractions from least to greatest, we want to find common denominators and then look at the numerators in those equivalent fractions. When I order 3/10, 1/5, 3/4, and 1/3 from least to greatest, I want to first create equivalent fractions in which all of the denominators are the same. Notice that 10, 5, 4, and 3 have a common multiple of 60. And if you weren't sure, I would recommend listing out those multiples for these denominators. Then I would create equivalent fractions in which the denominator for each of these were 60. 10 times 6 is 60, therefore 3 times 6 is 18. 5 times 12 is 60, therefore 1 times 12 is 12. 4 times 15 is 60, therefore 3 times 15 is 45. And 3 times 20 is 60, and 1 times 20 is 20. Now I want to choose the smallest of these numerators. That will be my first fraction. 12/16. Notice 12/16 is 1/5. So 1/5 is my smallest fraction. The next smallest is 18/60, or 3/10. Third is 20/60, or 1/3. And lastly, 45/60, that's 3/4. So 1/5, 3/10, 1/3, and 3/4. When plotting fractions or mixed numbers on the number line, take note of the increments on the number line. Sometimes you'll have a mix of positive and negative numbers, or just positive numbers, or just negative numbers. When you have a mix of positive and negative numbers, numbers to the right of 0 will be positive, numbers to the left of 0 will be negative. As you move to the right, you're increasing in size, and as you're moving to the left, you're decreasing in size. Even though the numbers look like they're increasing, that negative means they're decreasing in size. When plotting your numbers on the number line, look for the increments in which that number is surrounded by. For instance, -1 and 1/3 is between -2 and -1. Then look at the denominator. It's in thirds, so I can visually divide this space into thirds. Since I have 1/3, I can mark the 1/3 past the 1. So -1 and 1/3 would be plotted here. I'm going to mark it on the number line with a closed dot or circle. Here we have 1/2. It's a positive, so it's going to be between 0 and 1. And I've got 2 equal parts. 1/2 would be right in the middle. Lastly, I have 2 3/4. Again, this is a positive number, so it's going to be between +2 and +3. My denominator is in fourths. I can visually divide this into fourths, 1/4, 2/4, 3/4. And so I would plot my point here, 2 3/4.